In this video, I'm going to introduce you to the very basics of textual analysis. Textual analysis encompasses a lot of tools and a lot of different techniques. And so we'll start slowly here and then over the next few classes build up a repertoire of tools that are used mostly with accounting information to try and analyze textual data. Although these tools are applied to all kinds of text, we'll focus on the accounting angle. And then by the last class of dealing with text, we will go back to predicting earnings like we had done before, but now we're going to incorporate textual information. So we're going to start out with a new package here. This is the stringr package. And this is mainly just for convenience so we can pull down some reports. And this package pulls down the text of the reports or the entire filing. It doesn't pull out specific financial statements or other numbers. There are other packages that do that, but it's fairly straightforward. So let me just walk through this package. So the first part is this user agent. You have to put in your email. The reason for that is the SEC has started to crack down on using these sorts of packages, and they want to make sure it's a real person, and they can also track who is doing it so that they can limit if someone is overusing these requests. So you probably don't want to do this and run thousands of these very quickly, because then it'll kick you off. So I'm just going to pull Amazon, this get filing info. This function tells you what filings they have. And the reason we need this is because then it gives us information about how to use the other functions. So we can put in a name here. We have to put in the years that we're looking and the quarters that we're looking for. The reason we need this is because it's going to pull all the filings. It's going to pull a giant index of all the filings for those periods, and then it's going to keep that. It's going to put it in our working directory, so then we can go and get it from there. So get this filing info. I'm saving it as an object info. May take a minute. Oh, I forgot to get user agent here, sorry. Oh, I think it might have already been saved in there. Okay, so we look over here at info. Notice it says we've got Amazon. It tells us what the form type is, 10K, because I required that. That's their annual financial statements. It gives us the date that they were filed and the financial year that that's related to, or the fiscal year that that's related to. The main thing that we wanted was this CIK code. This is the company identifier that the SEC uses. So I'm just going to pull out that CIK code. So notice it says get from the info object, the column CIK. The first instance of that. Now that gives me the CIK code. Sorry, I've got other stuff in here right now that we'll get to later. But I have in here somewhere, well, somewhere in here I have the CIK code. If I didn't have everything, oh, there we go. So the CIK code here that I can use to then go into the next function. So here it says get filings. So now it's actually going to download the filings that we want, and it says CIK.no is the number for the CIK. So here I'm putting in the CIK code that I got. I'm only getting the 10K filings. Of course, we could increase the number of CIKs here. We could put in other ones, and we could put in other filings. I'm only going to get 2006 for any quarter in 2006. Download said, do you want to let it download? We could change this to yes. The reason it does that is to prevent huge downloads, so you don't automatically just download everything. So the default is no. So run this. Notice it says it's downloading the filing. So if I look in my working directory, so get my working directory, this is where mine happens to be. You could go look in that working directory. So go over to files here and look in your home one, and you see, let's see, what was my users, J Green? Oh, here we go. So these get stringr data cache, this is where, oh, maybe it's not cache. It is Edgar filings full. Let me go back here. Edgar filings full text. There we go. So it puts it in your working directory in this folder here, saves it in by the form, saves it by the CIK code. Then here is the text of that full filing. So then if you get your working directory, you can paste in your working directory here, and then the rest of this should be the same. So Edgar filings, full text, form 10K, then the CIK code that you got up here, and it's going to paste those together to make the full file path. So here it's going to list the files that are in there. So once we do that, it gives you over here the file. This is the file path that gets you to the file that you want to get. Then we're going to read in the file as text. So do all of that. Now here we have the text, and it's not going to give you everything. That's because it's huge, but here it begins. This is the text that we're pulling out of that filing. So if we want to look at just a little bit of it, the first thing we might see is this substring. So substring just breaks up text into pieces. So it takes a character string, breaks it up into pieces. So that character string, if I want to get the go from one character to another character, so I'm going to start, this is the starting point, this is the stopping point. So I'm going to start at character 1, go to character 1000, and substring just pulls out that part of the text. So notice here it gives me this part of the text down here. This is the beginning of what we have in this text file. Well, right away we see some of the problems that we encounter with textual data, and this one is a great example of that. We've got some information that is actually useful. So it says this, let's see, period of report. That's the date that the report covered. The file date, here's when it was filed. So that stuff is useful. The company name, Amazon. So some things are useful here, but then we get all of these other markup things and other nonsense that we don't actually need. So this is where we start to need to use what are called regular expressions to clean up the data and use it, get it in a format that we might be able to use it later. There are some other functions that do some of this automatically, and that's useful, but you need to sort of understand what it goes behind it. And sometimes there isn't a function that does exactly what you want, so then it's nice to have some facility with this. So regular expressions are useful, and there's this cheat sheet here you could go look at that I think is very useful to go look at. So if you don't have experience with regular expressions, then this is really useful. So there are all these cheat sheets here for different things. I'm just looking for the stringr one. So the package is called stringr. And this gives you all the functions that you can use. So lots of different functions, and they're just ways that you can work with strings, or so characters. And these are the parts that make the regular expressions. So let me just talk over them just a little bit. But the concept is you give, instead of just giving a specific, let's say you want to match Amazon in there. Well, if you already know you want to match Amazon, then it's easy. But if you don't, or if there are different spellings or different ways to put it in there, then you want something that matches something that's like that, but not exactly that. So for example, let's say you wanted to match a character that says any sort of word in there. Well, this /w, \w matches anything that is a word character. Or this \d matches anything that's a number character. And in R, in stringr, in order to use this is the regular expression. If you were to use it in any sort of package, like in a different language, this is what you're looking at. But in R, in stringr, we have to do double backslashes. So in order to get this \w, we have to actually put in double \w. So we always have one extra backslash when we're trying to do these things. So if you've done this in a different language, the difference is we're adding another backslash. So we have these different things that we can use to match. We can use some other techniques too, so we can match, match one thing or the other. We can match at a certain position, so the beginning of the line or the end of the line. We can match before and after certain things. So these lookarounds here go before and after. Lots of different techniques to try and pull out specific information from the text. We're going to use it now just to clean up the text. And so if I don't, get it really clear, or you want to do something else, this cheat sheet is a great way to go after looking at it. All right, so the first thing we're going to do, just so you can see how it works, string detect is go find something and tell me if it's there. We're going to pull it from the text. So this is the data, the text we're going to be using. Regular expression here tells it to use regular expressions. So this whole part is the part that's going to do something. And the regular expression starts with the pattern we're trying to match. That's this part. Then these are just convenient. So Perl equals true means it gives you some other functions you can use in the regular expressions. Ignore underscore case equals true means don't worry if it's uppercase or lowercase, match it no matter what. Now there are some other ways to do this. We don't actually need these. We can use them in other ways and normal regular expressions, but I find it convenient to do this. So here we're going to say, okay, find Amazon. Do you find that word in that text? And it says true. So somewhere in there it found Amazon. Notice I put it all lowercase, but here we see it is uppercase. So it could have just matched. It went through, started here, and then the first time it encounters this Amazon, it doesn't worry that it's uppercase here, and it just matches this. Okay. So string extract is to pull out certain sections of text. So sometimes we don't know what we're looking for, but we can find a pattern that will help us pull something out. So in this case, let's try and pull words before and after Amazon. So let me show you what this looks like, and then we'll talk through it. So here it's saying get Amazon here, then go 20 characters after and 20 characters before and pull all of that out. Well, this is really helpful if you're having to look through a lot of documents and you want to just look at the sentence or the text right around some word. This is a nice clean way to do that. So let me talk through what that means. So dot means match anything. So match anything. Here this quantifier tells it how many. So I'm going to match anything, 20 of those. So 20 characters, 20 spaces it's going to match. Then find Amazon. Then match anything again 20 times. So we can change this 20. We can have a range. So we'll see this range down here later. Or we can have just a dot without these numbers, and it'll just give us one space. We could also put indefinite things. So here we have this star. So we could do match anything as many times as you can. That's what the star does. So we could do match anything lots of times, then Amazon, match anything lots of times. Well, that would just give us the whole text in the text file we have. Okay, so this is one way we start pulling something out. So let's try and do some cleanup now. And this is the string replace all. That says replace something. So now we have this regex part that we're trying to match, but then we're going to replace things that we find. So it starts with the text that we're going to do, has this regular expression. This is all for the pattern that we're going to match. And then comma this, it's going to replace it with an empty space. So nothing, or not even a space, just replace it with nothing. So we could put something else in here. Let's say this is how the find and replace part thing works in the Microsoft Word or Excel. We could put something in here, and let's say we had Amazon and we wanted to replace it with the Amazon ticker or something like that. We could use it that way. So this is a way we're going to clear up all of these. See how we have these HTML tags in here. So let's see if I can find one that well, I don't have one to show you right off here, but there are a bunch of them. Let's go back to this maybe. Let's try 1000, the 1000th character to the 2000th character. Maybe that'll get us something there. There we go. So we've got some of these tags in here. So notice we have the opening tag, some stuff, and then the closing tag. So we've got a lot of this in here. Well, that isn't really text that we can use. It's just formatting. So we want to get rid of all of that. So this is how we're going to do it. So it has to match an opening sign. I can't remember what that's called. An opening sign, and it has to match a closing sign. So then the question is, what does it allow in between those two? Well, here it says match anything. The star says match anything as many times as you want. So the star is a modifier to this dot here. So it says match anything, do that as many times as you can. Then the question mark limits the matching. So so if we just use these two, this uses what is called greedy matching. And so it'll start with this, then it'll keep going forever until it finds a closing one of these, like let's say near the end of the document. So then this will match the whole document basically because it finds these two things in between them. The question mark says limit, stop as soon as you find the first one of these. Okay, so this is a modifier on what comes after it. So this says between these two signs, match anything as many times as possible, but stop as soon as you get to the first one of these. So we can do this and replace it. So I'm replacing the text, replacing this text where it is matched to this, replacing it with nothing, and changing the text to that. So I'm stripping out anything that matches this pattern. So then we can look at it again and looks sort of similar. That's because I didn't clean it out. So let's try this again up here where I changed it. And notice it got rid of, well, we didn't get rid of all of it, but we got rid of some things. So let's see. Yeah, so here it starts with this opening, it ends here. So the reason it doesn't match there is because it has, the dot is not matching everything. So the dot doesn't match when it goes across a line. So what has happened here is there's a line that it encounters in between, which is this. This is the next line character. So it didn't match across the lines. So if we wanted to do that, then we have to tell it to match across the lines. And we can come back to that at some point. But so one way to do that, so let's move this up. Let's move this one up here first. What if we want to get rid of all the new lines and just make it one block of text? So the \n, \r, \t, these are tabs and lines and returns. So it's just telling it how to format this. So one way to do it, these square brackets say take exactly what is in between these and match those. So, and it does any of these. So in the square brackets, it goes through each one of these. Find anything that is the \n, find anything that is \r or \t, and treat those individually. So we're not trying to match this pattern that's here. If you didn't have the square brackets, then it would try and match that exact pattern, and because these are special characters, it would ignore those. All right, so let's remove these first. So if we just look at the text here, you see we lost these \n and \t, those are gone. Then if we go back and remove these HTML tags at this point, and then see the cleanup, now notice it got rid of all of the HTML tags. It got rid of the new line characters, and then you notice it's got a bunch of other garbage here too. So it's not clean, but it's getting closer to something we could use. Let's try one more. So we have these really long things here. Well, we could say, let's find something that is just a really long word, or that looks like a word without any spaces or anything. Maybe we can get rid of those. So here I'm going to say, find a word character that is at least 20 and at most 1,000 characters. So somewhere between 20 and 1,000 characters, and we're going to replace that with nothing. So we can do that again. And it cleaned up some of these. It didn't get all of them because we had a space here, notice. Had a space here. We have some pluses here. So we have some things that it didn't match, but it got rid of some of this long stuff here for us. So we're getting closer and closer to something we might actually be able to recognize as text. So we could continue to do some of this. Let's go ahead and do something where we want to actually understand what's happening with the text. So here, let's say we want to pull out what the date of the report is. So, I mean, the date that it covers. So period of report, I looked in here and see that it says period of report, has a colon, then it has a date here. So what if we want to pull that out? So we know that it says period of report, so that's easy. We just put it in as it says it. If a different document had a different format, we would have to be more flexible with it, but that's easy to start. But the date for each document is going to be a little different, so we just want it to pull out numbers, not the date. So the ~D tells us pull out digits, and plus says do one or more numbers. So the star would say 0 or more, the plus says 1 or more. So it's going to look and find period of report and at least one number, and it's going to keep going until it finishes numbers. So here in this one, it keeps going, up to there, it's good. It'll go forward one more. That is a character, a word character, so don't use that. So it's going to back up, and then this will be the part that it matches. So we're just going to pull that part out so we can go ahead and see. Notice now it's given us the period of the report and the numbers. So we can start to get what we want. Let's use a look behind, which is very similar to that, but now we're going to only capture the numbers instead of this whole part. Well, one way we can do that then is do what is called a look behind. There's a look ahead and look behind. So how these regular expressions work is it's going to travel through this text, and it's let's say it's looking for this digit. So it's going to travel through, and it goes one step at a time. Number, looking for a number, looking for a number, looking for a number. No. Keeps going, bam, I got a number. So then it says it finds a number. Now it's going to look forward for as many as possible. Okay, now we're up to here. So it's currently standing at the after the 4. Then it's going to go ahead and look and do anything else that it says to do. And here it says before you get to the first number, so that we put it in parentheses, and then this part here tells it look before we get to this point. There's another one that says look ahead, which is just the question mark equals. So look before this and find period of report. So down here it would say, we find a number, look through all of this, look before that, period of report, no, it's not there. So it fails. So then it keeps going, and it's going to keep looking for another number. And forgot, oh, here it is. Okay, sorry, we wouldn't have been there already. So here it looks for a number, fails, didn't work, looks for a number here, finds the numbers, looks backwards, period of report, it matches that, so then it's going to pull out that. And here, because it just looks behind, it doesn't actually match it, it just checks to make sure it's there. So if we run this, notice what comes out of that is just the numbers itself, so now we have the date of the report. So similarly, if this starts to become helpful if you have lots and lots of documents where you're trying to do this. If it's one like we're doing right now, it's not so helpful. So let's do another one like what we did before. Let's say we want to look in here and find anywhere it's talking about expenses, and we're going to look 20 before and 20 after expenses. And here I'm going to string extract all. That says every time that shows up, not just the first time. So if we do string extract here, it's going to only go to the first time it matches that. Here, it'll go through the whole document for every time it finds that. And so it gives us a lot of them. So we can go ahead and look and see what sort of happens here. Although marketing expenses do not include the, significant portion of our expenses and investments is. So notice it's talking about expenses here. It's not completely all understandable because we still have some markup stuff in here that doesn't really make a lot of sense because it's just formatting. But it gives us some idea if we were going to try and understand what they talk about with expenses, we could use this sort of thing. So if we wanted to narrow it down, let's go to one more case where we narrow it down. Here I mentioned this dot all equals true. This means make the dot match anything, including new lines. So that's what that modifier is there. Here we're going to do deferred, then match anything 1 to 20 characters worth. So now it gives it some option, okay? Expense, then match anything 20 times only. So what this is going to do is capture everything that anything that comes for 20 characters after expense. But between deferred and expense, it's going to match anything from 1 to 20 times. So if it's just one time, let's say it's just going to match a space, so it could be deferred expense. That'll match that. But it could say deferred tax expense now because it could go up to 20 characters. So let me show how this works. So notice it says deferred income tax expense. It allowed those to come in between deferred and expense. Here it said deferred tax expense. So it allows different options while still matching the basic things that you want to match. So these sorts of things become really helpful if you want to pull out specific things or try and simplify what's there in the data. All right, so let's do a couple of other things that start to get us on the line of how this is used frequently. So let's try this first one, number of characters. We can count how many characters there are in the document. So 376,000. Well, what if we want to count the number of words? Well, we have to define what words are, but this string count function is, we'll do a string split function too, but a string count function is how many times does it find this? And if we define a word as saying any word character as many times as that word character shows up, but then after you hit that word character, right, if it gets to a number or a space, it'll stop. So it's going to split everything into how many times it can find this pattern, which is just word characters that all go together at one point. So notice we have some mess here, like NBSP, that's a tag, and it isn't a word, but it's going to count that as a word because it's just word characters in a row here. So it's going to overcount a little bit. But it tells us we have 59,000 words in the document, which is more or less, right, that's close, but still have some issues. We could do the same thing by splitting up the string. So here it says string underscore split it everywhere it has that word. So if we go over to A here, notice what happens. The first time it splits it into dashes, nothing, 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 nothing. And then eventually, let me see if I can pull out some of this. So there's a bunch of this that it's nonsense, okay? Because these things are counted as word characters. So we could remove punctuation and clean it up a little bit more. And we don't even get to where this works. Well, at some point, it'll let us, we'll get to, it's 59,000. So I wonder if we could go, let's try. Let's do The 30,000th one, it's nothing there. Oh, whoops. I'm not having much luck. Well, and I don't want it to give us the whole thing, but we'll see. Nope, it stops before we get there. Well, all right. So then the next thing we would want to do is remove anything that is missing or anything that has punctuations, and then we could go ahead and split on the words. So again, lots of mess to clean up as we go through this. We'll do that actually later on some automatic ways to remove that, but we could go back here where we're removing things. So replace, we could replace any punctuation as well. So I guess we might as well do that while we're here. So let's go back to the cheat sheet. So I just want to show you, so if I said I want to get rid of punctuation, I would go here and look and see what does that. Ah, look, this tells me punctuation. So I could try and remove punctuation like that. So let's say we go here, we're trying to replace all. And I'm just going to remove can't remember if it's, oh nice, I closed it out. I don't remember, is it double? Oh, just a single one of those. And it's P-U-N-C-T. N-C-T. Okay, so then what it should do is replace everything that is a punctuation. And maybe we should replace any double spaces with single spaces. So we have one space, two spaces, replace it with one space. There are other ways to do that too, which we could go over later. Okay, so then let's go back here and see if it happened to help out here. Now we've got a bunch of single space ones. So how about let's try one more thing. Oh, and it's leaving $sign not as a punctuation. So let's get rid of, let's get anywhere we have a space. Anywhere we have two spaces. We have one space here. Anywhere we have, well, just for the sake of this, am I going to use this later? No, we're okay. So put anywhere there is a space, let's put no spaces. All right, let's see if that sort of gets us there. Now we've got a bunch of $signs. So, well, eventually we could keep, removing more, and then we should get to where we can actually start to see the words. But moving on, we can come back to that later if we want. So then, how do we know? So this gives lots of individual words, so it just split them up into pieces. So notice it says there were 888 of those. So we can do the lengths of A, and it needs an S here. And it says 888 of those it finds. All right, so we can say something like 888 words. Not fantastic, but it, basically it gives me something. All right, so then let's go to another thing that starts to get into analyzing the text. And one of the ways that we do this is to come up with some dictionaries that, which is just a list of words that tell us something is good or something is bad. And that's how we calculate things like sentiment. So here I'm going to create a pattern that is this word, and then the line here, the vertical line is or. So this word or, this word or, this word or, this word. And notice, so I just went to the thesaurus and found anything that said increase. And so I'm just finding words that they might use that is related to increase. And notice I use what are called stems. I don't use the whole word. So I could use increasing, increases, increase. This will match any of those. And so you're using word stems to make sure it matches more of those. So I have a pattern. I'm going to look in the text, and I'm going to count how many times those show up. It says it finds 238 of those instances of these words. So we might then call that positive. It has 238 positive words. Of course, there are lots of different dictionaries, and you could come up with different words, but this is a way to go after it. And let's do one that is negative that we'll talk about decreasing and stuff and similar things, right? So we could go and look how many of those it says. Well, it says 153. So let's do negative. So now we have positive and negative words, or maybe I should say growth and decline words. And then we combine those in some way to say the document is positive or negative. So here, one of the ways is just to do the difference between those. So in that, we call that sentiment or net sentiment. So the net sentiment would be the number of positive minus the number of negative. So that would give us 85 net positive words. Sometimes that isn't super informative, so maybe we just do divide by the total number of words we have found. So divided by the number of positive and negative words. That gives us 21% or 22% net positive, so it gives us something to think about. Or one that is often used is divide by the total number of words in the document, which we now know is a little bit of a problem, but will give us something sort of related. And notice that's about a 10% of the words are net positive. So when we start to do these things, this is called a bag of word approach, where we collect a dictionary, collective list of words, count how often those words show up in the document, and then determine whether, use those counts of words to be something that identifies the meaning or the sentiment of the document. Next class, we're going to start to work on moving beyond just doing a count of words, a simple count of words anyways, into other techniques that are used. This one has been used most commonly in finance and accounting, but using different dictionaries. So they created a huge list of things that are positive and a huge list of things that are negative, and they use that, or different versions of that.